Okay, so in this demo here, we'll be looking at another separation technique known as distillation. Usually the glassware that we use for this setup here is actually a round bottom flask. It's named because of its round bottom here. Usually you would have a heat source that basically wraps around this round bottom here. It heats up a liquid here. We're going to basically be separating things based on different boiling point. If you imagine this food colored water here, the blue food coloring in the water as two different chemicals. If one of the chemicals boils easier than the water, one of them will boil off first. In an open system like this, the gas would just escape out the top. But we're going to see with the distillation flask here, by running it through a condenser, we basically let it form a vapor first, and then we're going to recondense it. Another way you can do it here, this is sort of mimicking what's called a rotovap setup. We have our sample solution here inside this water bath, as simulated here by a beaker. Fancier setup, though, this is called a rotovap. It's a evaporator with a sort of rotating motor that will actually just sort of heat up this flask here uniformly. My water bath here is going to typically heat the liquid inside. The gas, again, is going to just evaporate, boil up the top. We would seal the top. You basically shunt the gas here down the side, arm valve here, and then again this valve here through a condenser to actually get the distillation set up. So because we don't have access to rotovap here, I'm just simulating this distillation here using a sidearm flask here. So here's just an Erlenmeyer. There's an extra sidearm here. We usually use this sidearm here for an aspirator. In this case here, I'm just using it so that I can actually let the gas travel through that into the condenser. So we're gonna have a look at this distillation setup here. So I just have some water boiling away there. Because it's going to be building up a lot of pressure, even though I do need a closed system so that the gas can sort of escape, I didn't form an overly tight seal here so that it doesn't build up too much pressure. As you see, the water there is just boiling away here. We're going to imagine, let's say there's two chemicals in there. One chemical boiled first, let's say chemical A. Chemical A starts separating from B because it boils off first. That chemical here is going to travel through the sidearm, through this rubber hose, into this water condenser here. As this gas here travels through the condenser, remember the center of this condenser here is almost like a tunnel. The chemicals just sort of make their way down the central chamber here. Around the outside though, we're just running cold water so that when that hot gas arrives here, it actually recondenses and then just forms droplets here. Basically, I want to keep the solvent after it's been vaporized here. I don't want it just to escape as gas. The gas recondenses here. I give it a little bit of a slant here, so those little droplets of distillate here are going to come through. Because this solution here has gone through a distillation apparatus here, we call what's collected here the distillate, and then our remaining solution will be left over here. For the condenser here, just to sort of hook up the cold water, we have cold water just coming from the tap here. It's going to enter the bottom of this condenser here. It's going to fill up just the outer walls of this condenser. Remember, the outer walls are actually not connected with where the chemicals are actually being condensed. They're just providing a cold environment for the gas to eventually just condense back into liquid. To prevent this condenser from overflowing, we just run the other side of the condenser just down the sink here. I have it clamped down, and then basically the water just goes into the sink. So just another look at the distillation setup. Okay. Again, we're separating things based on different boiling point. Thanks, guys.